Okay, so we'll get started. I think we're already a couple minutes late, and we really have to stick to the schedule on this one. So the speakers will receive a warning after 4 minutes. My name is Jean-Luc Montchamp. I'm professor in chemistry and biochemistry, and I'll be hosting this session of the Michael and Sally Student Research Symposium, which celebrates research at TCU. I guess we'll start immediately. So our first speaker is Lauren Burden, and she'll be talking about volcanic hazard assessment of Kilauea lava lake.
Hi, let me share my screen really fast. Just 1 second. Maybe. Okay, can everyone see that? Yes, no, I hope so. All right, so I actually ended up assessing the Hawaiian population on the Big Island of Hawaii in high volcanic zones due to Mauna Loa's recent activity and Kilauea's current activity. So just a little background to start off, Hawaii is home to one of the largest volcanic or active volcanoes in the world. It's actually Mauna Loa, not Kilauea at the moment. That's according to the USGS. Right now, Mauna Loa, it's situated in the center of the island, and it's been recently moved from a green level of volcanic hazard activity, like advisory level, to a yellow level. And what this means is because of recent seismic activity, they kind of are starting to believe that it could erupt again. And currently, Kilauea is active in an east fissure vent that lava is flowing through. So the objective of my project was just to assess the total population of Hawaii that lives in high volcanic zones. And these zones include extremely high hazard, very high hazard, and high hazard. So I'm looking at the three main ones. The data that I used for this project was from the US Census Bureau of 2020 and the ArcGIS portal. Mainly I use the ArcGIS portal just for simplicity and to make it easier to work with more updated lava maps than anything else really. So first what I did was download the US Census Bureau and convert the Excel table of the population into a graduated colors map, and then I had to normalize the data. And what normalizing means is taking the population within each polygon and then dividing that by the square miles within the polygon. So that way, when you have larger polygons, like you can see in figure 1, where it seems like the data or the population is denser, it's not. It's just that it's a larger area. So they're automatically assuming that there's going to be more people in that area. And then I took the volcanic hazards zone map that I downloaded from the ArcGIS portal, and I clipped it so that way you can only see the first 3 high hazard zones. So once I did that, I combined both the attribute tables from the US Census Bureau and the volcanic hazards. So you can see in this final figure down here, the most extreme high hazard zones, they're outlined in this bright red. And then you have the bright orange that outlines the very high hazards and the yellow for the high hazards. And you can see that these polygons of the population, they're actually lighter colored than you can see up in this first figure, due to the fact that this one up here isn't normalized while this one down here is. So you can see there's a higher concentration of people along the coastal areas, which is what you would expect in Hawaii. And for the results, the total population on the Big Island is actually approximately 185,000. And of those 185,000, 81% are in the first 3 high hazard zones of lava flows. So what I then did is I took the average amount of people that are in each zone, and I made it into a percentage of those who are at risk of those 3 zones, and then those of the total population. So As you'd expect, because most people are on the coastal areas in just very like high hazard zones.
Lauren, sorry, but you need to really wrap it up. We are on a very tight schedule.
Yeah, absolutely. Okay, so pretty much 64% are in high hazards. And what we can do with this map is that with the growing population of Hawaii, we can use it to make sure people are prepared for possible eruptions when they do come. So yeah, thank you.
Thank you. I forgot to say that you can ask questions in the chat. Only I will see them, so I can ask them then, or right now, if you have a question, feel free to ask it. But please, let's stick to the schedule. Anyone with a question? No question at all? Okay, well, if not, thank you, Lauren, and we'll move on to the next talk, which is from Drew Kiampa, revealing the physical properties of the leading arm using cloudy simulations.
Okay, am I good to go? Okay. Hi, everyone. I'm Drew Ciampa. I'm a PhD student in the Physics and Astronomy department here at TCU. And I'll give you a little introduction to some of the work I'm doing. It's a relatively new project, but yet still exciting. And that'll be just looking at the leading arm, which is a cluster of gas surrounding the Milky Way. We're running some simulations to sort of unveil some of the properties of this gas, look at maybe the origin, how much of it is there, things like that, fun stuff. So before we get started, I'd like to first describe what is the leading arm. So we reside in the Milky Way, as we all know, and that's depicted in this gray material here in this figure. Surrounding us, there's millions of complexes of gas that surround us, but in particular, there's the leading arm, which is a group of clusters of gas, and that's shown by this orangey yellow material here. And there's different types, different clusters, one called the leading arm 1, another leading arm 2, and then in the box, leading arm 3. That's particularly where my research is taking place. And I zoom in here to show you what the actual structure looks like. So this is neutral hydrogen, so it's just a bunch of hydrogen that's surrounding the Milky Way. And in particular, we have two green sightlines here, UVQS and NGC 3125. Those are the sightlines and the locations on this complex that we are looking at in particular. All right, so what are we looking for and why do we look for it? So first off, we know there's material there. We see it there in that figure on the right, but how much is actually present? What mass is here? And then remember, this is astronomy, so we could deal with millions of times the mass of the sun worth of material that resides there. And why this is important? Well, it's a bunch of gas. And if this gas is captured by the Milky Way, it can create the next generation of stars, solar systems, and possibly planets that harbor life like our own, right? Next question we really want to know is, what type of material is inside of this gas? Is it just hydrogen, or is there carbon, other elements, and what's its overall composition? And the reason we want to know this is it gives us sort of a fingerprint of this gas. And if we can match that fingerprint with other gas surrounding the galaxy, well, maybe we can associate the two clusters, paint a little picture of its origin and where it came from. And also, has this material been ionized? Ionization happens when it involves some energetic activity affecting this gas. Again, this is just to paint a picture. Where is this gas coming from, and what sort of life did the gas live? So how do we do it? Right here, I want to leave this blank except for this single spectrum, and that is because it's the critical part of our data set. A spectrum is just looking at some light from a source, right? And this source is going to be behind the gas that we're looking at. And as that light travels towards us and as we observe it, some of the material absorbs that light and actually creates these dips that you see right here. Now, if we specifically look at this dip and we measure how large the dip is, we can discover things like the column density or line ratios. And what this tells us is it tells us how much material is actually absorbing that light. And if we know how much material is there, we can do this for several different elements like silicon and carbon and hydrogen. And if we have all those measurements, we can throw it into what I described before, some models, some simulations. Those models will then predict what type of environment can produce these column densities and output things such as mass, temperature, pressure, and the overall environment, right? And we see here that if we take this measurement, and it's just a sample output, we see that our gas has a temperature of around 10 to the 4 Kelvin, right? So it's a short presentation, so I'm already at the results, but the preliminary results, remember this is early research, we find both locations have temperatures around 10 to the 4 Kelvin, right? The ionizations, so the processes that affected this gas seem to be similar, and there's a spatial connection that we see with this bright material. This is not groundbreaking news. It's part of the same complex. We almost expected this. The exciting part is the future work, where we'll continue to run additional cloudy simulations. We'll look for any small differences. And also, if you remember, we had those leading arm 1 and 2. We'll look at those to see if there are any similarities with this material and those. And if there are, maybe they come from the same origin. Because again, at the end of the day, we just want to find our place in the universe and the material surrounding us. Where did it come from, and how the role of that gas plays in our near future, right? So I'm going to leave up the SciComm statement for you guys to briefly read, and please feel free to ask any questions you may or may not have. Thank you.
Thank you. I want to remind the audience that you can ask the questions via the chat, and normally I should be the only one. Someone has a question?
I don't see any.
I'll ask one. You mentioned the near future. Is it like in astronomy, the near future is what?
It's not tomorrow, so don't worry. Everyone can relax. Honestly, it's over the course of 10 to 100 million years. Yeah, so it's larger timescales than mine excite a lot of people, but in astronomy, that's still a very, very short timescale. And again, this is material that's really close to us, so it can directly influence our evolution of our galaxy within the near future. I saw something in chat. I didn't know. I can't actually see it.
I'm not seeing anything in the chat.
Oh, okay. That might have been just a wrap up your presentation notification.
Well, it's good you stuck with the time. I actually had another little question. So you talked about the composition of the gas, and that it's mostly hydrogen, but you want to know if there is carbon and so on. But aren't the most elements actually made by the stars? So would the gas come from, I mean, where is the gas coming from?
So yeah, that's actually a really good question. And what we're really looking for, and I didn't want to get too in depth with it, is the gas has a certain amount of hydrogen, helium, and a bunch of other metals. Astronomers call metals anything heavier than helium. But what we're really looking for is how much of the different ions exist. So silicon can be ionized certain number of levels, and we're looking then how much silicon 2 is there or how much silicon 3 is there, and looking at these relative ratios to sort of describe what temperature must exist to cause that. So it's not actually additional new elements, but also just the relative abundances of those elements in the gas itself.
Okay, well, we have to move on. Thank you. Our next speaker is John Reeks, and he's going to talk about surface photovoltaic studies of zinc oxide microcrystals in relation to their antibacterial action. Is there a technical issue? On my screen, you are listed as unmuted.
Oh, it's telling me I can't share the screen.
Oh.
I mean, do you, okay. Okay, can everybody see it?
I can. Go ahead, please.
Okay, so as you said, I'm John. I'm a PhD student in physics doing surface photovoltage studies in conjunction with antibacterial studies of zinc oxide microcrystals that we actually grow in-house. Investigating the mechanism of action behind zinc oxide nanoparticle antimicrobial activity is not a new topic, but it's still for the most part unresolved. There's many hypothesized mechanisms of action, from the production of reactive oxide species causing oxidative stress within the bacteria, to metal ion release, where zinc can replace iron in certain metabolic processes, causing mismetallation and other issues with reproduction and metabolism of the bacteria cells. It can also physically damage the cell wall just through physical contact between the nanoparticles and the bacteria. And there can also be internalization. If the particles are small enough, they can go inside the cell and mess with the internal workings and thus cause bactericidal activity. Through our studies, however, we focus not just on what happens to the bacteria, but what happens to zinc oxide and how its services affect these processes. So we found that the inhibition of bacterial growth is not as dependent on being super small. So the particles don't have to be nanoscale to inhibit growth. We show comparable growth inhibition from commercial grade nanoparticles, or it's comparable to our homegrown micron-sized particles that are much larger than the bacteria. As you can see in this figure, the little circles would be Staph aureus cells, and the large hexagonal prisms are particles. So since it's clear that size isn't important, we also, through SEM studies, noticed that physical damage was happening to the surface of the zinc oxide crystals, noting that there's some process going on driving interactions between the crystal surfaces and the bacteria. And we were not only seeing damage, but even possible phase changes among the zinc oxide crystals, where they go from these relatively uniform hex shapes to what we observe to either be a new phase or just degradation of the zinc oxide crystals. So it's clear to us that fundamentally the mechanism of action driving this antibacterial process is rooted in surface-surface interactions between the crystal surfaces and the bacterial surfaces and the extracellular material. So with that in mind, we decided to focus our studies on the surface charge dynamics, which would dictate the available surface states, the surface chemistry of our crystals, and what goes on near the surface. So if this is one of our samples, we can do what's called surface photovoltage, which is essentially measuring the change in electric potential at the surface with a given illumination of light. So if you look at this graph here, we see a very strong drop off in contact potential difference, or surface potential, at around what is known to be the band gap energy of zinc oxide, which is basically the energy gap between the allowed states of the valence band and the conduction band. But if we zoom in on this relatively flat region, which would be illumination with energies below this band gap energy, we can see transitions of much smaller voltages, but these transitions represent either transitions of electrons from the valence band to the surface, from the surface to the conduction band, or from within surface states. And depending on their direction, it tells us information about the direction the electron's going. And this lets us know about the surface chemistry, what absorptive or chemically reactive states exist on the surface, and how they could possibly contribute to antibacterial action, since some defect sites are known to catalyze processes producing reactive oxides, or add atoms can catalyze process involving the release of metal ions into the growth media. And so understanding these allow us to understand how, in comparing it with the antimicrobial results, we can see any correlation between given surface states weighing their contribution to the antimicrobial action. We're also doing surface photovoltaic studies before and after introduction to bacterial media to see how these surface states change or are modified after interactions with bacteria. Are there any questions?
Any questions? Normally, you should be able to use the chat feature to ask questions. Okay, there is a question, which is, what's the errors on the electron volt values that you measure?
I guess right here on this slide.
Yes,
Usually, I want to say within hundreds of MeV. We do see transitions that are in the range of expected values for transitions to certain defect states. But I guess we do see a range of, about 100 electron volts with some of them.
Okay, unfortunately, we have to move on. The schedule is really tight. So thank you. Our next speaker is Michael Hembrough, and he's going to talk about shoreline spiders as sentinels of mercury contamination of the Trinity River. Michael.
Thank you, Dr. Monchump, and thank you everybody for being here. My project focuses on methylmercury contamination of the environment. That's one of the most important environmental issues in our world today. This is important because methylmercury is a hazard to vertebrates because it's a neurotoxin in the environment that reduces the reproductive success of vertebrates. This occurs when mercury is first emitted into the atmosphere by anthropogenic sources such as coal emissions, and it then sits in a global atmospheric pool of mercury. And this non-toxic mercury is deposited into aquatic ecosystems, where it can then be converted by bacteria into toxic methylmercury, which is also the bioavailable form of mercury that can enter food webs. So that methylmercury is going to enter algae at the base of the food web and bioaccumulate or increase in concentration as it moves up the food chain. And it can eventually impact humans through the consumption of fish, or terrestrial predators such as birds through the consumption of insects or shoreline spiders that feed on those insects. Now, this problem of atmospheric emission occurs globally, and so all aquatic ecosystems throughout the globe are contaminated with methylmercury. And that leaves us with a huge challenge of monitoring the levels of this bioavailable contaminant across the millions of miles of aquatic ecosystems in the world. So as a solution to this problem, scientists have proposed sentinel species, which serve to map the bioavailable fraction of pollution in an ecosystem by retaining the pollutants in their tissues, or in other words, they serve as a representative of the amount of pollution in an ecosystem. I want to direct your attention back to this mercury cycle slide I showed you earlier. And you see on the right side of the figure here that shoreline spiders feed on emergent insects that are contaminated with methylmercury. And for that reason, shoreline spiders have been proposed as sentinels of mercury contamination of aquatic ecosystems. Now, there are a number of traits that make these spiders ideal sentinels. First, they're contaminated with aquatic pollutants due to their diet of emergent insects. They are widely distributed, highly abundant, and they are easily sampled. Now, thus far, most studies have focused on the long-jawed orb weaver shown here. While over 30 studies have measured levels of environmental contaminants in long-jawed orb weavers, none of those studies actually use those spiders as sentinels to explore levels of contamination in unmonitored environments. So our objective was to test the hypothesis that long-jawed orb weavers can be used as sentinels to evaluate methylmercury contamination of river food webs. We did this by collecting spiders from both the Clear Fork and the West Fork of the Trinity River here in Fort Worth. And these sites were collected because a previous study showed mercury contamination in both of the forks. That study, interestingly enough, also suggested that the Clear Fork might be more contaminated than the West Fork, which we did not know previously. However, their sample size was not large enough to confirm this relationship. So that raised the question, do the two forks of the Trinity River actually have different levels of mercury contamination? So our approach was to conduct a more robust study of mercury in spiders and fish in the Clear Fork and West Fork of the Trinity River to see if that relationship would actually hold true. So we collected a total of 1,150 spiders from the Clear Fork and West Fork by hand between June and August of 2019. Those spiders were then preserved in 95% ethanol. Their leg length was measured as a proxy for body size. They were then sorted by leg length into different size categories, dried and composite, and they were analyzed for total mercury using a direct mercury analyzer at TCU. And then their percent methyl mercury values were derived from the literature. This figure shows the results with mercury concentration plotted as a function of spider size for the Clear Fork in blue circles and the West Fork in pink squares. And with 5 times the amount of spiders, we confirmed that the Clear Fork increase as mercury concentrations increase as a function of spider size in the Clear Fork, but not the West Fork. And also that the Clear Fork had higher concentrations of mercury than the West Fork. So this suggests that the food web of the Clear Fork is more contaminated than that of the West Fork. And this hypothesis was tested in a parallel study by Simon Gall, who conducted a study in bluegill fish between June and August of 2019, collecting about 60 to 75 bluegill from each of the two forks. Those fish were euthanized in a bucket of MS-222. Their total length was measured. They were sorted by size categories into total length, dried and composite, and their mercury was analyzed once again using a direct mercury analyzer. Simon's results are shown here with mercury concentration plotted as a function of bluegill length. And as would be predicted by our spider data, mercury concentration increases a function of length for both forks, but the increase is much weaker or smaller in the West Fork. And more importantly, the bluegill from the Clear Fork had much higher levels of mercury contamination than those of from the West Fork. So from this, we can conclude that mercury concentrations in long-jawed orb weavers accurately predicted that methylmercury contamination was higher in the Clear Fork than the West Fork, as was confirmed by the study of bluegill. And more importantly, this is one of the first studies to show that shoreline spiders can be used as sentinels of mercury contamination of river systems. As you can see here on the left, the long-jawed orb weaver is widely distributed across North America. So this spider can be used as a sentinel of methylmercury contamination, not just here in the Trinity River at Fort Worth, but all across the United States and North America. I'd like to thank our committee members, Dr. David Minter and Eric Simonik, as well as TCU students Garrett Wallace, Amal Khan, and Paxton Shiro, and of course, TCU CERC funding for making this project possible. Are there any questions?
Questions?
Sure.
So far, I'm not getting questions on the chat, so
That's okay.
I'll just ask you one. I guess you are not an arachnophobe then.
No, I'm not. I was before this a little bit, actually.
Really?
I got pretty comfortable around them. But
Is there a certain way to grab them or?
yeah, we wore some gloves so that they wouldn't bite you or anything. They're pretty tame usually. You just pick them up by they usually just sit on webs or on their webs or on plants kind of like this, and you can grab them by their kind of front legs, and they just kind of freeze there, and then we just place them immediately in the alcohol and euthanize them that way. So it was honestly pretty easy to collect.
Okay, I have a more scientific question. So
Okay.
you are doing this because the insects or whatever you are measuring are actually concentrating the mercury. You can't directly measure, let's say you take a gallon of water from the river and determine how much mercury there is.
No, so that's a good idea, obviously, and there's a number of reasons why that's not possible. So first of all, because of bioaccumulation, the mercury concentrations in water are much lower, and so it's really hard to get an accurate measurement. There's also there's not just methylmercury in the water. There's a number of mercury species, so that can interfere with the measurement. Water is a dynamic system, and so you take a sample of water from one place in a river one day and come back the next day, and the concentrations of mercury could be completely different. So that's an issue as well. And then also, most importantly, because there are multiple mercury species in the water, the mercury concentration in the water doesn't tell us the bioavailability of methylmercury or how much it's impacting the food chain or the vertebrates higher up, which is kind of the significance of the study. So,
okay. Thank you very much. We have to move on. The next talk is from Zachary Hoyle, and the title is Loist Senior Design. in engineering.
Thank you, sir. So do I just share my screen here?
Yes, please.
Okay. Sorry about that. So hi, my name is Zachary Hoyle. I'm part of the engineering senior design team. Dr. Robert Biddle is my advisor. And so what we did in our senior design testing and building was we built a dryer for limestone for a company called Lost. They mine limestone. So one of the problems that they have is they, when they mine the limestone, it needs to be dried. So our task was to build a small scale dryer, which rotates and uses lifters. And we basically built that and then started testing. So that's kind of like a little bit of an overview of what our project is. And then the actual testing objective is to optimize which lifters to use based on what lifters will dry fastest. So the two types that we have are the radials. So it's just straight up and down, mounted inside of the cylinder. And then you have the other one is the 90-degree lifter. So it just goes up and then goes like this. And so it veils the material. So kind of like why this matters is it's gonna vary with the moisture content that's coming in as opposed to like what's coming out and how it dries. The best drying is going to be the one which creates the best veil throughout the cylinder. So one of the problems that we were having, since the cylinder is on a incline, is that the material falls out and it kind of falls off the side of the lifter. So we built these cardboard components to try to keep it, the material on the actual lifter for the longest time possible. So we have videos of the two side-by-side videos, so you can actually see like how the difference is. I know that was kind of quick. Let me play that again. So you can kind of see on the left, the material falls into the outside of the cylinder faster than the ones with the cardboards does. So, and then we did the same thing with the radials as well. You can kind of tell like the veiling. That's the difference in the veiling. And then moving forward, so this is the testing parameters that we had. The cylinder's rotating at 10 RPM, 10 revolutions per minute, putting about 5 gallons of material through. And we're starting the videos at around 20 seconds. And then this is the next task that so once we kind of optimized the lifters and found all that, we wanted to know how long it took for material to actually get through the cylinder. And so what that depended on is we actually took the different configurations and then put a different material. So this material we used was kidney beans. And then we did like sampling. So after about 10 seconds, every 10 seconds, we would take a cup at the end, sample how many beans were in it, and then try to find a distribution from there. So that's kind of like what we're working on now. So you can this is kind of like the intro to that if you want to watch this video. Okay, I know that was kind of a quick run through, but thank you for your time. And I was wondering if anyone has any questions.
Thank you. I guess I have a couple of questions because I've seen this thing in the machine shop. it's pretty impressive, I thought. Although it has something of a, torture device from the Middle Ages to it. But I was curious, why do you use beans instead of limestone?
Yes, sir. So we obviously would like to do that because the densities are different between the beans and the limestone. But the reason why we can't use limestone is once it's operating at steady state and we add another scoop of limestone, it's impossible for us to tell how fast that scoop that we just put in actually gets through the cylinder. So we'd have a different material so we use beans, and then once we sample it, they actually mix very well. It's not like they're just, the beans are on the bottom and then the, limestone's on top or something like that. And once it hits those lifters, it's just chaos, honestly, going on inside of that cylinder. So sampling it is actually pretty accurate, I would say.
Okay, and so they want to dry the lime. It's going to be the whole piece of machinery will be heated, or it's air that's heated?
Yes, sir. So I think once we actually hand it over to them to Lost, they'll probably use dryers on the other side, like actual heating elements.
Okay.
But as far as what we are using right now, no, our limestone is just as it is, and we're just using it on a smaller scale. They actually have these similar cylinders, but they're like 300 feet long. They just our parameter, or our kind of mission is, we worked on this last semester, got this thing ready to go, and then this semester we actually started testing and trying to optimize which lifter combinations would dry the fastest.
I have a question from the audience. So did you try different rotation speed?
Yes, sir. So we started at 5 RPMs, which is like almost excruciatingly slow if you actually watch it. And then 10 RPM is the max. So those are parameters that are set from Lost themselves. So I think that those are the ones that they actually use in their full scale models, is anywhere from 1 RPM to 10 RPM.
Okay. Thank you very much.
Thanks.
Our next speaker is Jeremy Lee, and he will be talking about an efficient, low-cost notification system for technical support requests via Internet of Things.
Thank you, sir. So I will share my screen. All right, so hi everyone, my name is Jeremy Lee, and I'm a student from the engineering department. I'm working with King Wing from computer science under the guidance of Dr. Colin Gong and Dr. Lee Ranma on IoT-based low-cost notification system for technical support requests. So in this presentation, we will discuss about the current issue, our solution, in which we will talk about the Amazon Web Service, IoT button, and system architecture. Next, we will go into detail about the potential use case in classroom setting. Finally, we conclude with our future work. First, communicating important messages across all channels to any number of people is the key to building joint force to achieve successful outcome. Therefore, notification servers are widely used nowadays in many scenarios, especially technical support in classroom setting. As you can see from the picture, classrooms nowadays are equipped with many technology to assist professor lecturing. However, an interruption caused by a technical issue in the middle of the lecture could lead to the student disengagement and uncomfortable atmosphere for everyone in the classroom. There is a purple sticker on the left side of the picture for contact information to the IT department. When such issue occurs, the instructor would call this phone number for help, which is wasting lecture time. To address the situation, we developed a one-click notification system that allows the instructor to send a request to IT with just a simple click. Our system is rather simple, low cost, secure, and reliable. First, we talk about the IoT button. After being very successful with Amazon Dash service, Amazon also released a version that is configurable for developer to repurpose. It uses it to their own need. We use the Seed IoT button by Seed Studio as our primary device. As you can see, the side of the button fit perfectly in my hand. The IoT button is a programmable button and it's very easy to connect to the Wi-Fi. It comes with a different click type, single, double, and long press that can be taken advantage of to perform multiple actions. It also comes with the LED indicator for Wi-Fi connection, charging status, and communication to the cloud. It can either be used with the chargeable battery or directly plugged into an outlet through a USB-C port, receiving a constant power. So what exactly is Amazon Web Service? AWS is a collection of cloud servers that provide fast, secure, and reliable resource. It also provides a low-cost serverless service called AWS Lambda, where the logic of the system only gets executed whenever there is an event. Otherwise, it just sits there in the cloud. This diagram below describes the system architecture and how our notification system works. The key component of the system, including an IoT button and several AWS functions, including AWS IoT one-click, AWS Lambda, Amazon DynamoDB, API Gateway, AWS Simple Notification Service, and AWS Simple Image Service. In our implementation, we use a button to send the event to the IoT one-click, which then triggers the Lambda function. Then the Lambda function accesses the DynamoDB and performs some computing to retrieve the sender information. It subsequently calls AWS SNS and AWS SES to send notification to the IT phone number and pre-verify with the email address respectively. The API gateway can be used for client-side application to do some administrative tasks such as monitoring the notification record. So when there is an interruption caused by a technical issue with the system at hand, the instructor instead only needs to click the pre-programmed IoT button, continue the lecture, and wait for the IT person to arrive. As mentioned above, IoT button comes with 3 click type, single, double, and long press. A single press, or the easiest to perform, is used by the instructor to send technical support requests to the IT department. The instructor can also cancel the request by performing a double click on the IoT button in case equipment magically start working again, or in case they manage to fix it. After the resolution takes place, the IT person will perform a long press on the button, indicating the task is accomplished. The IoT button is easy to use user interface. However, there's some constraint in the setting of the classroom because people other than the instructor might cursively press the button. To eliminate unwanted requests, we integrate some constraint to our system that would ensure that every press of the button is a valid one. The first restriction is that the button press only legitimate during class time period. The second constraint is that only the instructor can send requests. In conclusion, the system rather is easy to use and cost-effective to implement, which provide a reliable solution that can be applied to multiple settings. In the future, we plan to deploy our system into several classrooms on TCU campus to test its capability in the real world. Moreover, we wish to analyze several characteristics of the system, such as availability, reliability, etc., during deployment. Thank you for your interest and attention. Does anyone have any question?
Thank you, Jeremy. Any questions? Again, remember, if you have questions, you can use the chat. I don't really have a question. I just think it's a miracle when things work. So. There is a question. How fast can the request reach the IT department?
Sorry, could you repeat the question again?
How fast is the request reaching IT?
So like the first time that the button is clicked, it will probably take around 10 seconds for the person to start to like warm up, and then after that the button will just reach the IT in like 5 seconds. The first click is like 10 seconds, but after that is like 5 seconds.
And another question is, if you are working with TCU IT when you were doing this work?
Yes, we're working with Josh Tully. He giving us the opportunity to test the system at the university, like in Region.
So it was based on one classroom or?
Yeah, you can use this button as any classroom in the campus.
Hmm.
As long as it have the Wi-Fi connection, as long as it has connection to Wi-Fi at TCU, then you can use it anywhere.
All right, thank you. Our next speaker is Damon Ramirez, and the talk is COVID tracker. I guess it's up to date. Damon?
Yeah, hi, thank you. Let me get my screen shared here. We can get started. Here we go. Sure. All right, so hey, y'all. My name is Damon Ramirez. I'm the project leader of the COVID tracker team. The rest of our team includes Zach McAdam, Kwong Nguyen, Nicholas Bell, and Joe Donahue. And our faculty advisor and also our client on the issue is Dr. Bing Yang Wei from the TCU Computer Science Department. And we are all in the computer science senior design class. So basically what our project is an online dashboard that presents information based on the coronavirus to the user in a way that is easy to use and not as like cluttered as some of the other ones you see online. So what the main problem we were trying to solve was that there's a lot of these dashboards online that you can find, but you get to them and they're very hard to read. The information is presented in a way that is cluttered and it's almost overwhelming when you try to read it, and it kind of stresses you out as you try to figure out what's going on. So our main goal was just to make our own version that is as easy to use as possible. So I'm going to show you the main features here. Can we still see the screen with the that it changed? Yes, no. Okay, well, I'm just going to operate under the assumption that everyone can see our dashboard.
Yes, you can.
Okay, good. So the main features I want to touch on here are that all this information is related to coronavirus. And our main feature is this map here that shows the different data types as you click on them. So right now we're just showing all active cases, but we can also show new cases every day, the amount of total deaths due to the pandemic, the amount of people that have been vaccinated, and the amount of people that are in the hospital currently. Problem with the hospitalization data is our source stopped updating after March 7th. So you can only see hospitalization data up until that point. But we go back to cases. These numbers right here at the top show the total numbers for each one across the United States. You can change the date to view data up until that point, or like if you wanted to see how many new cases there were on February 11th, you can do that, but we're going to stick with April for now. And then each of these buttons controls the map. And other features included are these graphs here at the bottom that show the weekly, monthly, and yearly changes in the data. These will also change when you change the data source. It's a little slow. So now this is all new cases by day, by week, and by month. We also have a news feature here at the bottom. My screen is a little compacted, so it's usually on the right, that has up-to-date articles about the pandemic. And then at the top of our screen, if I move my box, we have information related to the virus's symptoms, how to get vaccinated, and then information about our team. The architecture and tech specs that we use to create this, we have a MongoDB database that updates nightly with pulling from our data sources to get the data for every day. We also use React.js and a bunch of different components to create the web page and display all the data. We'd like to thank Dr. Wei for everything he's done to help us so far. He's been a very easy client, if I can say, just because we have a great relationship with him already, but even more of a better mentor and a teacher for us along the way. And then our data sources we use are down here at the bottom. If anyone has any questions, I'll be happy to answer them.
Yeah, there is one question. Is this available to the public?
Yes, sir, it is. I stopped sharing. If you see here at the bottom, this is our URL, and this QR code should reach the our site.
Okay.
Yes, sir.
Another question is what's available by state?
I guess I didn't actually click on a state. Let's go back here. I'm still sharing, correct?
Yes.
I don't know why I didn't do this. When you click on a state, it will zoom in and show all the same information, but now for the counties. So if I was to hover over Tarrant County, I can see how many cases there are. I can change that to deaths, and it'll load. And if I hover over Tarrant County again, I can see how many deaths there are up until this date. I guess that's Denton County. And then the graphs here at the bottom change to only reflect the Texas data now.
So I had a related question in terms of the states. I think it was Wyoming that was always like lighter color than the other states. And my question is, do you take into account the population of a state when you show the statistics? Because obviously, you know, a highly populated state like California or Texas are going to have more cases, right? So is there like a way to correct that?
At this point, no, that's a great question, but we just display the data based on the number that of like cases or deaths that each state has. What we're implementing right now that's like kind of in the works and wasn't ready for the presentation is a legend that displays the scaling, and it will also show the population of the US or the state, so like the scale relative to the population. But when the shades of the colors will only correspond to just the total number of cases or deaths and so on and so forth.
Thank you.
Problem.
Do you have to pay to maintain this website?
So right now we're using a free version of Heroku to deploy it. We're switching to AWS just because the free tiers of Heroku don't have enough storage to automatically update our data every night. So you would, like what we were doing was having to go in and do it manually. But with the free tier of AWS, it has plenty of storage for us.
Thank you very much. Our next presentation, the speaker is Eric Estrada, and the title is Registered Dietitian Recommendation for Nutrition Education and Interprofessional Education in Medical School Curriculum. Thanks for the title. That was a nice one. Eric?
I see we have something in the chat, but I didn't check.
And Olivia Spears in the chat.
Just time.
Olivia Spears in the chat is also a co-host.
Yeah, unfortunately, we are out of time, so feel free to email them directly with questions. And thank you guys for your presentation.
Thank you very much.
Eric, can you get the show on the road, please?
Yes.
Switch over to our next presenter.
Oh, can Olivia Spears also be added as a co-presenter?
I just need to be unmuted. There I am. Okay, hi guys. So today I will share my presentation. So hi, my name is Olivia Spears,
And I'm Eric Estrada.
and we will be presenting our presentation for registered dietitians recommendations for nutrition education and interprofessional education in medical school curriculum. So to start off, the current state of nutrition education is that the National Research Council recommends 25 hours minimum of nutrition education in medical school. However, most medical schools actually do not meet this recommendation. And even more concerning is that most medical schools' education in nutrition is actually on the decline. So at this point, there is a well-recognized evidence practice gap that exists between the nutrition knowledge, skills, and attitudes needed for nutrition care and the nutrition education provided to medical students. So from the physician's perspective, so since the early 2000s, the World Health Organization has listed many nutrition-based diseases in their top 10 causes of death. And doctors really do have the ability to promote a decline in these nutrition-based diseases. However, most medical students, residents, and physicians do not believe that they have a strong foundation in nutritional care. And that's because most medical students do not get that nutrition education in their medical school.
So the purpose of our study is twofold. And firstly, it's to determine and understand RD and RDN's perceptions of physicians' nutrition knowledge in order to enhance nutrition education in the TCU and UNT Health Science Center School of Medicine curriculum. And secondly, to determine the interprofessional practice of physicians from an RD's perception. So the methods of our study was a descriptive cross-sectional study, and our participants were recruited through email and social media platforms. We had 64 RD participants within the state of Texas that were recruited from alumni and professional networks. And our questionnaire was sent out via SurveyMonkey and was about 10 minutes and consisted of 19 questions. We used frequency and percentages to describe the characteristics of our sample. So here's an overview of our participant characteristics. You can see that the female population does seem to be skewed, but this is actually quite representative of the RD field. And here are more characteristics with age, time as an RD, and time in the dietetics field. So our first free response question was, what do you want physicians to know about RDs and RDNs? And with 40.6% of respondents said that RDs are experts in nutrition and healthcare, and someone said, we are nutrition experts. We have studied nutrition for years and know the importance of nutrition on health. Second was RDs are a vital part of a patient's care team, with one respondent saying registered dietitians are an integral part of the interdisciplinary team. And thirdly, the role and job description of RDs, with someone saying registered dietitians do so much more than just tell people what to eat and what not to eat.
For our next response question, we talked about, we asked participants, if you were going to design a nutrition course for medical school, what 3 focus areas would be covered in your course? And so for the top 3 respondents was medical nutrition therapy, basic general nutrition, and nutrition in the ICU, closely followed by RDs in the health team, as well as intuitive nutrition. So for some of the questions, we're going to go over it. Black is well below expected, gray is going to be expected, purple is well above expected, and then white is non-observable. So for our first question, we asked the RDs if physicians establish collaborative relationships with RDs. And that, it's pretty split on how they felt about this one. And then when asked if they feel that physicians are well prepared to educate their patients in nutrition, most did not agree with this statement. And most also did not agree that physicians are properly recommending and monitoring dietary supplements, which has really big effects if you're not monitoring these supplements and whatnot, because they can have serious consequences. So in conclusion, nutrition education in medical school is recommended to better equip doctors to execute primary prevention for nutrition-related diseases. A strong nutrition foundation is currently lacking for physicians, and research shows that physicians actually feel the same. So at this point, we recommend that medical schools meet or exceed the recommended 25 hours of nutrition education?
So results that we expect from our recommendation are to increase physician-patient nutrition discussions, to increase physician primary prevention methods, which could lower the overall healthcare costs in America and increase positive patient outcome. And some limitations to our study were that we had a small population size of 64 RDs, the participants were only recruited from Texas, and voluntary status of the survey could produce a self-selection bias.
And these are our references. And does anyone have any questions?
You mentioned some of the diseases that are associated with poor nutrition from the World Health Organization. Can you give us a few?
Yeah, so diabetes would be one, cardiovascular disease, and many cancers are actually related or connected with your diet.
Okay, thanks.
Yeah.
Questions? So why did you choose this project?
Well, I presented on this as my honors research, so we had to cut some slides to make it smaller. But the reason was because the TCU UNTHSC School of Medicine, actually it's a long name, reached out to the Department of Nutrition at TCU and asked what their recommendation for a course, like for what should be incorporated in their curriculum. And so as a result, we did a study to see what RDs recommended, because at this point the literature is pretty well established that physicians do not feel that they have a strong foundation in nutrition, and it's very obvious why. They just don't get it. And so usually they have to do their own study of nutrition, like looking up information and teaching themselves, which at this point I believe that medical schools should be really doing that. And so yeah, so that we use this information to give it to the TCU School of Medicine.
Okay, thank you.
Yeah, of
We're
course.
moving on to the next talk, which is from Delaney Oakes, and it's about smart homeopathy doctor application. Delaney, we need to get started.
Oh, it wasn't letting me unmute or share. Okay. All
Okay,
right.
it's working now.
Yes. All right. Good afternoon, everyone. I'm Delaney Oakes, and I'm the team lead design project.
There is terrible feedback. Can you hear me?
Doctor app. The rest of the team includes Bob. Can you guys hear me now?
Yeah, now it's fine, but we couldn't hear anything the past 20 seconds. Go ahead.
Can you hear me?
Yes.
Can you guys hear me?
Yes.
Let me turn off my video and share it screen. All right, can you hear me now?
Yes. Proceed, please.
So homeopathy what? Okay, so homeopathy is a holistic natural system of medicine. Homeopathy helps patients recover naturally from all types of illnesses while strengthening the patient's can do some research on the app for, is it cutting in and out? Can you guys hear me now? I'm at this library. Okay.
No, sorry, it's really bad. We can hear you like a couple of sentences and then it's cutting out. There is like feedback.
I'm using my hotspot.
Yeah, that's probably the reason.
School library. Can you guys hear me now?
Yeah, we can, but every time you ask that, we can hear you and then it goes really bad, really fast.
Okay, well, let me just start with the homepage down. The lower left corner is our user-friendly page that provides the user with patient testimonies and articles about homeopathy. Next, on the patient management, here you schedule appointments, write a review through numerous websites, contact the clinic and our physicians, shop for remedies.
Sorry, I think it's the technology is not good on this one. We couldn't hear anything at all. So unfortunately, well, you have like a minute left.
Okay, well, let me share real quick and just show the poster. Here in the middle is the users. This is our main feature, which is users' ability to search for conditions of homeopathy. We ran into a major issue where we switched from our Firebase database from Heroku, which will it's easier to manage the data and allowed us to use only one database server and not multiple. We also ran into a challenge where we had to change the way that we formatted our database. So each condition is stored as a document and each query of a document is charged as a read. So Barbara devised a solution that changed the way the documents are stored, which limited the total document read count of each condition search, which in effect kept the cost down.
Thank you. It's too bad because we could really hear the last 2 minutes perfectly well, but we have to keep up with the schedule. I'm very sorry. Our next speaker is Connor Duncan. And the title of his presentation is Deforestation and Fragmentation. Oh, sorry, her presentation is Deforestation and Fragmentation in the Atlantic Forest. Where is Connor?
Hello, sorry about that. Yeah, I will be presenting for us today.
Okay, thank you. Take it up.
Okay, can everyone see this okay?
Yes, we can. Proceed, please.
Okay, hello everyone. My name is Annie Deck and my co-author is Connor Duncan, but I will be presenting for us today. And like we were introduced, we did deforestation and fragmentation of the Atlantic forest. So some background for those of you who don't know, the Atlantic forest extends over 17 Brazilian states. As shown in this image here, this would be an original forest range extent. And it's one of the richest biomes in the world. It's been a hotspot for important biodiversity, including endangered and endemic species. Sadly, despite this, only 15% of the forest's original range remains, which is crazy. And interestingly, this loss is disproportionately distributed. So 4 of the 17 states it expands through accounts for 90% of the loss. And this loss in our research we found is really due to just an increase in anthropogenic activity overall in Brazil, but more specifically logging and eucalyptus plantations have been the primary drivers of this deforestation, and really agriculture as a whole, which I'll talk about a bit more later. And so we were focusing on our objective for this project was to identify the extent of deforestation, specifically in the southern region of the forest, as shown in this red box here. That was kind of our target area, and we focused on the state of Rio Grande do Sul. So that's where we were focusing on acquiring our images from, and see if we could document, the extent of the deforestation. And our time period was 1994 to 2004. So getting into our methodology a bit, we acquired 2 images from Earth Explorer USGS, one from 1994 and one from 2004 respectively, as shown in image A here. We then uploaded these satellite images to ArcGIS Pro and created composite images for each, shown here in image B. The composite images were then uploaded to ArcMap, where we created a difference image between the two, as shown in image C here. We then used the unsupervised classification tool on the difference image we created with 6 subcategories, and we isolated the category that was representing deforestation, and we removed the other categories as they were not necessary. And the resulting layer illustrating deforestation we overlaid on top of the early 2000s composite image, the 2004 one, just to give visual reference on where the deforestation occurred, which I will show more in our results section. So our data, these were the 2 images we acquired right here. One from 1994, here's the 2004 one. We got them from the Landsat 4-5 satellite, the date once again, and the criteria we used was we needed these satellite images to have very low cloud cover, so it wouldn't skew the data or skew the data when we created the difference images between the 2 satellite images. So we were looking for images with low cloud cover. We wanted them to be in our target region, of course, right here. And we obviously needed the 2 images from each of the dates to overlap very closely. So that was our criteria. So here in the results section, they're a little bit bigger and easier to see. So our results were, we obviously documented significant change in forest cover You can really visually see the difference between figure 2 and figure 3 here, the significant change in coloration. And then figure 4 here is what I was mentioning earlier when we overlaid the deforestation layer over the 2004 image for reference. So you can just see there's a huge change. And we were able to calculate that for this specific area, 6,611.38 square miles was lost during this 10-year period. Also, on closer inspection, when we really zoomed into these satellite images and tried to find out what was going on here, why the deforestation was occurring, we found that agriculture here was what we believe to be the primary reason for the deforestation. We could see circular plots and what looked like agriculture in this area, which would make sense as we mentioned earlier in the background that agriculture plantations have been one of the big drivers. So that's what we suspect was the case for this particular region. We also noticed some areas, as shown in figure 4, were slightly more concentrated, with the red denoting the deforestation than others. We think this might be because the more concentrated areas might be larger scale industrial style agriculture versus more local smaller farms. And we really did not detect any reforestation efforts during this period or fragmentation. It really just seemed like widespread deforestation, at least for this 10-year time period. So our conclusions were, as I've said, we detected significant deforestation of the southern region of the Atlantic forest in this 10-year time period. We believe that the primary driver of this deforestation in this region was for agriculture. And though we note that it's a very complicated issue, we recommend that stronger regulations for deforestation are put in place and more reforestation efforts are put in place to protect the biodiversity that is left in this region. And that is all, and I can answer any questions anyone has for me.
Thank you, Annie. I have a quick question about the satellite photos. Is
Okay.
there like a specific treatment you do to color code them, or obviously there is a process. It's not just the picture, you do something to it, right?
Yeah, so just the raw satellite images we acquired from the website, and we didn't do any editing to those specifically. We just took the satellite images and then we did the composite. So based on the bands, the color bands of them. And then after that, we were able to do the difference image from them.
Okay, thank you very much.
Mm-hmm.
Okay, our next presentation is from Claire Clark, and the title is The Effects of Extrapolation and Trait Imageability on Self-Radicalization. Claire? I'm notified that she's not here, in which case we'll take a few minute break. By other member, you mean the next talk after that? Oh. Okay, so we have a break until 1:58 p.m. Guess I'll just use the time to remind people, if you want to ask questions, please use the chat. And I guess it's a pre-break before the official break. So we have one more talk and this session is done. While I have time, I'd like to thank Rachel Perez, who is the tech behind the scene and has done a really good job. Thanks, Rachel. All right, let's resume the session for the last talk. I guess it's fitting that the first talk was about a volcano, and this one is also about a volcano, although not in the same place. So the next speaker is Guthrie McLean, and the title is Volcanic Risk Assessment of Mount Rainier using Geographic Information System.
Hopefully everyone can see that fine. So I'm Guthrie. I wanted to go ahead and do a volcanic risk assessment, like say over Mount Rainier, using trying to see if I could do that with GIS methods. So a little background just to understand. So why are we focused on Mount Rainier? Well, back in May 18th, 1980, Mount St. Helens erupted, which kind of changed how the interest of the Cascade Range basically was viewed. And Rainier in particular is of interest due to the fact that it's within about 40 to 50 miles of three relatively large cities, with the largest being Seattle. And areas within this region all have past lahar deposits from Mount Rainier. And also all three of these areas are areas of relatively high population density, including increased population growth. So up here is my map of my study area that I wanted to look at. We have Washington, and these are the four main counties: King, Pierce, Thurston, and Lewis, that all have past lahar deposits from Mount Rainier over the last 1,000 years. So like I say, my main objective was to assess the volcanic hazard in the regions surrounding Mount Rainier, and then also look at population growth in these counties over the last 10 years, and see how it could be potentially effective of future eruptions. So I acquired a lot of my data mainly from the ArcGIS portal, including states, counties, cities, lahar data, earthquakes, and volcanoes. I had to pull the 2019 population data for the 4 counties from the US Census. And in doing so, I was able to make the following maps. So my methods in order to do this, I had to do a lot of extract feature layers in order to mainly focus on specific counties, states, and also specific data like population in order to do what I wanted to do. And in order to represent this, I used a lot of symbology, mainly in graduated colors, with darker colors representing higher risk areas most likely. So to go through the maps that I created, I'm going to go ahead and actually zoom in a little bit so y'all can see this a little bit better. So in figure 2, I went ahead and just did a population per square mile map in graduated color, with darker green representing a much higher population density. Up above here, we have King, we have Pierce County, this is Thurston, and we have Lewis County, all at which these 4 counties have past lahar deposits within the last 1,000 years. And over here, we have the 3 main cities of interest. We have Seattle, Tacoma, and Olympia here. Based on this image, I was able to assess that in terms of population density, King County is of the most risk, with the highest population density exceeding over 100 people per square mile, with Pierce County being closely second, and then also Thurston and Lewis being moderately low in risk, just due to population density. My next map, I went ahead and took the 2019 population data from the counties and normalized it with the 2010 population data of county population, and tried to see what, if anything, would change. In this case, King County still remained a relatively high ratio and indicating higher risk. Thurston County actually was higher than expected, with Pierce County being a little bit lower than expected, while Lewis County still remains very unchanged in terms of risk. Down here, I wanted to go ahead and do a seismicity. So I wanted to look at past earthquakes just to see what to expect in this case. We have some small earthquakes around Mount Rainier, but the point of this is to show that there is indeed seismicity going on in this region, which is of concern, as seismicity could indicate a volcanic eruption. So as said, I decided to go ahead and just, based on these images, I would say that King has potentially the most risk. However, based on past lahar deposits, I would say that it's probably moderate risk, and these past lahar deposits don't quite reach all the way to Seattle, which has the highest population density of the area. However, Pierce County, I would say, is probably the most risk, just due to the fact that much of these lahar deposits are within the interior of this county, and many of these deposits come very, very close to Tacoma and are within the suburbs. So.
Are you done?
Yes, I talked very quickly. I'm sorry.
Okay. Are there any questions from the audience? When was the last time Mount Rainier erupted?
I don't recall specifically off the top of my head. I think there is evidence of a small eruption about 200 years ago, maybe, but nothing of magnitude that we'd be concerned of. I believe the last very large eruption was a little bit over 1,000 years ago, which is where you have these lahar deposits that reach all the way into that bay. So it's, in terms of its past, they believe it is overdue, but like I say, I can't think of right off the top of my head when it last erupted.
And is Mount St. Helens close?
Mount St. Helens is to the west. I don't remember the specific distance, but I want to say it's probably about 60 to 80 miles away to the south, which its general area around Mount St. Helens, its population density is much lower per se. You don't have, especially as big of a city like Seattle near Mount St. Helens. But of course, it is obviously a risk.
Okay, last chance for questions. Well, if not, I'd like to thank all the speakers. I think, relatively speaking, things went well. Sorry we had to stick to the timetable. And thank you for presenting the broad array of research that you guys have done. So I think now we're going into a break until 2:15. Thank you, Guthrie.
Thank you.